All right, today we're going to talk about something you think you know, radar. Our source material for this explainer shows how it went from a top secret weapon of war to something, well, something a lot more personal. Let's get into it.
You know, our eyes are pretty amazing, right? But what they see is just this tiny, tiny sliver of reality called visible light. The world is just buzzing with other waves, radio, microwaves, you name it. And what radar really is, at its heart, is a technology that lets us see with those radio waves, to see a world that's totally invisible to us. Yeah, we all know the basics of radar. It tracks storms, it guides airplanes, heck, it might have even gotten you a speeding ticket. But what if I told you that's just the surface? According to the documents we're looking at, that's just the tip of the iceberg. There's a much deeper and, frankly, much stranger story here. So, the guy who wrote our source material, he actually started out as a radar operator in the US Navy. You know, watching that classic green line sweep around and around on a dark screen looking for blips. And that's really the core of it, right? Radar is just a system that blasts out radio waves to figure out where things are, how fast they're going, and what direction they're headed. You know, the way radar works is actually super simple when you break it down. First, a transmitter sends out a wave. That wave hits a target and bounces back, creating an echo. Then, a receiver snags that echo. And finally, a processor chews on the data to tell you what's out there. Transmit, reflect, receive, process. That simple loop, that's the key to everything we're about to get into. So, where did this game-changing tech even come from? Well, like a lot of incredible inventions, it wasn't born in a quiet university lab. No, modern radar was forged in the fire of desperation. It was a flat-out, top-secret race against the clock, driven by one terrifying threat: aerial bombing in World War II. Now, the basic idea had been floating around for a while. Way back in 1886, Hertz proved radio waves could bounce off stuff. Then you had guys like Popov and Holzmeier who saw the potential, but it was a really slow burn. Can you believe that? It took almost half a century of these little discoveries before Robert Watson-Watt in the UK finally put all the pieces together in 1935 and built the first real working radar system. Wow, okay, this slide really shows you just how fast things were moving once the pressure was on. On the left, you've got this early kind of skeleton-looking experiment from the US Navy, and on the right, from around the same time, is Watson-Watt's operational unit. You can just see the difference, right? One looks like a science project, the other looks like a tool built to win a war. In this tech, it wasn't just interesting, it literally changed the course of history. The Chain Home system was a network of these radar stations all along the British coast. It gave the RAF just enough warning to scramble their fighters and win the Battle of Britain. And when the cavity magnetron came along, making radar smaller and way more powerful, it was a total game changer for the entire war. But of course, the story doesn't end in 1945. Not even close. It just went dark. It went underground. The source material shows us that in the modern world, the focus of this technology shifted from tracking giant metal planes to tracking individual people, creating a totally unseen battlefield. Okay, so check this out. This is a document from the Snowden leaks. It talks about a project called Photo Anglo, a team-up between America's NSA and Britain's GCHQ. Now look at the details here. It's a radar system, but it's small enough to fit in a briefcase, weighs less than 10 pounds, and it's designed specifically for covert ops. Yeah, this thing isn't for tracking jumbo jets. And if you think that's just a what if, well, listen to this. This is a quote from a former agent, a guy named Carl Clark, and he's explaining exactly how it's done. He says you can use radar to track people anywhere, and that his friends in the special department could follow a target on their computers all day long. This is radar as a tool for constant personal surveillance. Okay, so this is where things get really weird. We're moving away from the declassified history and the leaked documents, and we're diving into some pretty wild theories from the source material. These are ideas that suggest radar's reach might go beyond just tracking our bodies, and maybe even into our minds. It all kind of kicks off with something called the Frey effect. And this isn't science fiction, this is a real documented thing. It's the ability to hear sounds, clicks, buzzes, even words, not with your ears, but directly inside your skull, all caused by microwaves. And here's the kicker. Who first discovered this? Radar technicians working near their gear. That was the first real link between this technology and what's happening inside our heads. And this is where a researcher named Dr. John Norcine takes that idea and just runs with it. He theorized that you could use a kind of radar sweep to actually map the thought patterns, what he calls semiotic conditions, inside someone's brain. He even suggested using Doppler analysis, like they use for storm tracking, to see if a thought is getting stronger or weaker. It's an absolutely radical idea, mapping the weather inside the human mind. So the source also brings out this other concept called a time-reversed wave. Think about a regular wave, right? Like from a flashlight. The beam spreads out and gets weaker the farther it goes. But a time-reversed wave, man, it supposedly does the exact opposite. It converges, perfectly retracing its path to deliver all its energy to one single point, with almost no loss. Theoretically, you could use this to zap a signal to a super specific target, maybe even a group of cells from far away. All right. That brings us to the last piece of this puzzle. And honestly, this might be the most mind-bending idea in the whole source. So far, we've talked about the human body being a target for technology. This final theory asks, what if our bodies already have the technology built right in? And it all comes down to the human eye. We're looking at a standard biology diagram here, right? We all learned in school about the lens, the retina, and those little photoreceptor cells called rods and cones. Their job is to see light. But some of the researchers in our source material looked at that same structure and saw something completely different. So before we go further, we need a quick primer on something called a fractal antenna. Think of your car radio antenna. It's tuned for one thing, right? To pick up radio stations. A fractal antenna is different. It uses these repeating geometric patterns to be like a master key that can pick up tons of different frequencies all at once. They're incredibly efficient. And this is where it gets crazy. This simulation models the geometric pattern of the rods and cones in our eye. And according to the source, what researchers found is that this biological structure behaves exactly like a fractal antenna. So what's the big takeaway here? The argument is that the very part of us that sees light might also be a biological antenna, built to receive a whole lot more. So let's just lay it all out. The theory is, plain and simple, our eyes are biological antennas. The source points out that the structure of our eyes contains the Fibonacci sequence, which is a key signature of fractal antennas. This suggests our eyes could potentially pick up microwaves, infrared, UV, way beyond just visible light. And it even connects to theories about beaming holographic images directly into our brain. So think about the journey we've just been on. We went from a simple green line on a Navy ship to a secret weapon that won a war, to a spy tool, and now to a potential interface with the human brain. The source material leaves us with this one truly radical idea, that the most advanced receivers on the planet might be the ones we're born with. And that brings us to the final question for this explainer. If our eyes really are antennas, what signals are we already receiving?